This is part 3 of the wall climbing system, which is the final one. So make sure to watch the previous 2 parts first if you haven't. First we will test the system up till now. It is mostly working, but there are some bugs to fix. Now we will do some bug fixes for the whole project and make everything work properly with each other. First is this error with a noticeable delay to the wall climbing pose. This can be fixed really easily by changing the overtime in this move component to a very small value like 0.05. Now it looks a lot better. Next is this problem with the same animation playing and not switching after the first half. I forgot to set wall climb land foot to right in the footstep _r notify, so make sure yours is correct. Then open the wall climb montage function and go to the climbing down montages. I put the wrong notify for these, so we'll swap them. Make sure the notify is the foot that is not hanging down. Moving up is working perfectly now, but the error is still there for right. Adjust the nodes as shown in wall climb montage. The animations are working correctly now. Next will be an error with the free hang. The diagonal movement adjustment is not working if trying to move up while free hanging and there's no space. To fix this, go to the free hang move multiplier function. Add a not boolean after the free hang move checks. Then go to the wall climb free hang trace function and change the default value of the multiplier input to 35. Now the player is moving up diagonally away from the free hanging leg to adjust themselves. Next is a really quick bug fix for this issue where the player stops climbing up where there are gaps here. To fix this, simply change max angle to 91. Now the player is not stopping. The next bug is visible for the first movement after entering wall climb. You can see the player sort of dips below, which shouldn't be like that. The fixes will be in the animation blueprint. First, change the joint target location of the right hand IK to -15, to -5. Then for the foot IK, multiply the current alpha by wall sliding knot. This foot IK was what was causing that dipping issue. Now the animations look much better. Next is this issue where both legs are free hanging only when one should be. To fix this, go to wall climb freehang tracer, and for this second one, remove the multiply by -1 for the multiplier absolute. Now only the correct leg free hangs. Next go to the wall climb hand IK function. Add the following nodes for the multiplier. Copy these changes and paste it in the wall climb hand IK correction function as well. Hand IK looks better now. There is a quick bug fix for the edge IK too. I forgot to switch the second one to wall climb hand IK right location. The animations are also a bit slow, so I will speed them up by changing the play rate of the montages. You can copy the play rates I use or adjust them to your liking. Now all the features we have made so far are mostly working properly. Now we will do the actor rotation aligning. Make a new function called wall climb rotation. There will be no inputs. Add a sequence with a sphere trace by channel for then 0. Copy the scripting shown for the start and end. The radius will be 20. Promote the return value to a local variable called actor hit. Break the hit result and make rot from x of the impact normal after negating the vector. Promote this to a local variable called actor target rotation. Duplicate the whole trace and replace the actor location with the head socket location of the mesh. Change the set values after it to new ones called head hit and head target rotation. In then 1, add a branch that checks if actor hit not or head hit not. If true, add a branch that checks actor hit. If true, promote actor target rotation to a new local variable called target rotator. If false, set it to head target rotation. If the previous branch is false, add a branch that checks if actor hit and head hit. If true, set target rotator to a lerp node with actor and head target rotation and an alpha of 0.5. This is so if both are hit the player will rotate to the average of them. If false, set target rotator to actor rotation. In then 2, set the actor rotation to AR interp node. The current is the actor rotation and target is target rotator. Delta time is the world delta seconds and set interp speed to something like 5. This trace does a trace from the head and middle to find a target rotation. 2 traces are done in case you are going up a wall that is changing normal, so it will find the average of them. This function you can call in the wall climb timer, but I found that it was not as smooth because we are using the R interp node. So instead I will call it in event tick, which is not the best method in terms of performance, but it was the smoothest. All the main features are now complete. The rest of the video will be final bug fixes throughout the project and final touches. First will be some issues with moving down. Go to the wall climb down trace and change the value of B in the select flow to 50 so the player can't move down to a wall that is further away from them. Then, change this greater than value to 10 and the in range value to 10 as well. Change this other greater than to 10 too. Now the player drops if there is no wall in front of them. The player also moves down sloped angles at a consistent speed. Next we'll be making it so the player climbs up more closer to the floor. For this, go to the wall climb to top trace function. Multiply the capsule half height by 1.2 before subtracting it. You can adjust this multiplier until it fits for you. Next we'll be fixing this issue where the player and rotation lags when transitioning to a sloped wall. For this, the best fix I could find was increasing the interp speed of the rotation in wall climb rotation. Next is errors with the hand IK. First go to the wall climb hand IK function. Add the following nodes for this up vector multiplier. Next add a select node for the IK found output. Get greater than of this distance vector and check if it is greater than 40. This is the index. If false, connect it to the trace's return value, and if true then leave it as false. Then go to the wall climb hand IK correction function. Change this multiply to -1.5 and the value of B in the select flow to 35. Now go to the spawn IK mesh event. Get the mesh's anim instance and cast to your animation blueprint. Set the wall climb hand IK left location from it to a socket location of the IK mesh. Set the same variable from the character blueprint as well. The socket should be hand_L. Do the same for both right locations using the hand_R. Now go to the animation blueprint. Adjust the setting hand IK location so it uses of interp 2, similar to the alphas. IK looks better now. Next we'll be fixing this issue which occurs when you are transitioning from a sloped wall to a straight one. The hand IK is not able to reach the target locations due to the position of the mesh. For this, we will add a spine rotation adjustment system. Make a new function called wall climb spine correction. Add a branch. Get the hand_L location of the IK mesh. Get the distance between this and wall climb hand IK left location. Check if this is greater than the same calculation using the corresponding right values. Then add a select float with the condition being the greater than. If B, then it is the second distance. Check if this select is greater than 10. This code is used to check the distance between the hand which is further away from its IK location. Make a new float variable called spine correction. Add a map range clamped of the select node with values of 10, 40, 0, and 25. Set this as the spine correction. If false, set it to 0. I will now comment the function. Go to the wall climb tick and call this function after each alpha being set for hand IK. Set spine correction to 0 at the end of exit wall climb 2. Now go to the animation blueprint. Promote the spine correction with the same f-interp setup as before. Go to the anim graph. Duplicate the transform bone before the two bone IKs. The bone is spine_02. The rotation mode is add to existing and rotation space is component space. For the rotation, split the struct pin and set the roll to spine correction and rest to 0. Select the freehang layered blend per bones and set the blend depth to 0. Now the player rotates at the top of the section and the hands are placed on the wall, which looks more realistic. The next bug is that when moving up with these gaps, free hanging is toggling on and off. The second one is when entering downward slopes the player is not close to the wall and looks unrealistic. To fix this, go to the wall climb freehang tracer. We will add a similar adjustment like we did for the spine. For the first fix however, remove the select vector condition and replace it will lock wall climb. Next break the traces hit result. Get the distance between the location and this make vector. Get greater than 55 of this and wall climb land foot equal right and add a branch node using it. Make a new float variable called left leg correction and set it for both true and false. For true, clamp the distance between 0 and 80 then set it. Duplicate this section for the other trace and swap the direction values and make a new variable called right leg correction for it. Set both leg corrections to 0 at the end of exit wall climb 2. Go to the animation blueprint and promote both of the new leg correction variables using the finterp setup. Go to the anim graph and duplicate the transform bone at the end. Change the bone to calf_L and replace spine correction with left leg correction. Duplicate it for the right leg and change the required values. The gap issues is still there, which we will fix soon. The leg correction is working but the amount is inverted. To fix the inverted issue, multiply both corrections by -1 before setting it as the roll. To fix the gap issue, go to wall climb freehang trace and change the values as shown. Finally swap the direction of both wall climb land foot equals. The freehang is no longer toggling on and off if moving. The leg correction is also working now. We can make this more precise by replacing the greater than in wall climb freehang tracer with an in range with min and max values of 55 and 80. Add a pin to the end node and check if lock wall climb not as well. Add these updates to the second trace as well. Next, go to the spine correction function and change the in range B value in the map range clamp to 70. Go to the wall climb rotation and change both move X multiply values to 50. The last fix in the project is to move the slot default slot after the control rig. That is all for the wall climbing system. The system is still not 100% perfect due to how detailed the IK and movement needs to be and all the conditions that will need to be met to wall climb, so you can add on to this if you find any. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.